In this week's lesson, we're going to be reviewing constraints on tables and columns, and in particular, primary and foreign key constraints. So what I have here on the screen now is the DVD rental entity relationship diagram, or ER diagram. So this diagram is common in data modeling, and data modelers would come up with this type of diagram, and it depicts all of the tables in the DVD rental database. There are 15 in total, and it shows the relationship between them using what's called crow's foot notation. So I'm going to go quickly over what crow's foot notation is. So there's basically 4 different types of relationships between entities, or in this case, tables, that crow's foot notation can display or show. The first one is a 1 to 0 relationship. So when one table has a relationship to another table that is 1 to 0, it means that the table may have 0 or 1 records that match in the other table. Okay, so it could be, for example, if someone has an employee table and there's a separate driver's license table, and we assume that there's only 1 driver's license allowed per person, the relationship between the employee table and the driver's license table would be this type of relationship, a 0 to 1. You may have no driver's license, or you may have 1 up to 1 valid driver's license. Another type of relationship is the 1 and only 1. So that means that there must be a minimum of 1 record in the matching table that matches, and there's a maximum of 1. So that's what 1 and only 1 means. Another relationship is this 0 to many. 0 to many. This is where the crow's foot comes in. Looks like a crow's foot here. So this says that the relationship between 2 tables is there may be no records that match. There may be 1. There may be 2. There may be a million. No limit. That's the many part of it is not limited. So that's what 0 to many means. And last, there's a 1 to many. So this is saying that between 2 tables, there's at least 1 record that must be in the here matching, but there could be 2, could be 3, and so forth and so on up to unlimited. So that's what crow's foot notation is all about. So let's go back to the ER diagram, and we can see here that film, which is one of the central tables here, is looking like this. And you'll notice that there's a column called film ID. It's defined as an integer. Okay, and 4 means 4 bytes. There's a little key in front of it that tells you that this table, film, has the film ID as its primary key defined. That means that this table, film, has records that can be uniquely identified by the film ID. So the film ID is unique from record to record. It'll never repeat. So it is the key to finding a unique single record back from this table. Okay, for example, if the ID of 1000 existed in this table, it only exists once. And that's what the primary key means. You'll notice that film has a relationship to film actor down here. You'll see that there's a connector here. And so film actor is for a given film ID, which is from film, it'll combine that with the actor's ID from the actor table. So the combination of those 2 together in this table, film actor, forms the primary key. That's 2 columns. So what you're seeing here is that a primary key can be a single field or a single column. It can be 2 columns. It can be 3, 4, or 5 or more. In general, you don't want to have that many columns to be the primary key. Okay. As a matter of fact, when that happens, what you're going to want to do is define what's called a surrogate key. Okay, and a surrogate key is a single column that really has no business meaning to it, and actually film ID, actor ID, and all the IDs in here really have no business meaning in of them. In other words, if we look into the film ID, will that tell us what type of film that is? No, it's just a number. It's not really related to the film at all. So it's called a surrogate ID because it's not taking one of the columns here that actually has business meaning and elevating it to the primary key status if it can do that. For example, some might think that maybe title is a good candidate for a primary key. But think about it. Primary keys are not null, meaning they cannot be blank, and titles are usually not blank in films, but they also cannot repeat in any two columns. So that would mean that two films that have the same title would not be able to be put into this table if this was the primary key. So title is not a good candidate for primary key. So this designer decided to use the surrogate ID concept to have a primary key defined on every one of the tables that is not business related, has no business meaning in and of itself. The value inside of it is only intended to ensure that every record that's in that table is unique. But the IDs are also used to link to other tables. So you'll see here that film can have 0 or 1 actors in it, right? And there are multiple actors that can be assigned to multiple films, okay? So you'll notice that when there's a primary key relationship, there's going to be a 1 and only 1 or a 0 or 1 relationship here. So the only time you're going to see the crow's foot, which is the many, right here is a many, is examples where there's a different type of relationship, which is known as the foreign key relationship. So let's look at this one for a minute. It's saying that addresses can be on 0 to many different customers. And that's because if I was a customer, I'd have my own ID in this table. If my wife was a customer, she'd have her own ID. If my son was a customer, he'd have his own ID, but we'd all share the same address ID. So this address ID, which is our address, is all the same, yet we're on we matched to 3 different customer records for that one address. So that's why it's a 0 to many. Some customers may have no addresses stored, but some addresses may be in here attached to 1, 2, or more customer records. So you notice here that we can say that address ID is a foreign key into the address table. See, because address ID is the primary key of the address table. So one table's foreign key, address ID here, is another table's primary key, address ID for the address table. You'll see that all over the place. So, for example, an address can contain a city, okay? Matter of fact, an address contains 1 and exactly 1 city. That's the 2 lines here, 1 and exactly 1. It wouldn't make sense to have an address without a city. But city, in relationship to address, can be attached to 0 address records, 1, or unlimited. So the relationship here is that city ID is a foreign key in the address table to the city table, which has city ID as its primary key. So that's a general explanation here of this entity relationship diagram and how to understand the usage of it. In the next video, or next part of this video, we'll now look into the actual DVD rental schema and database and look at some of the code that is defining all of that. So let's look at the film table. That's, again, one of the central tables. And you'll notice that film ID, as we talked about before, is the primary key. And here is the constraint defined on the table, primary key film ID. And as you learned from your lesson that you actually could have done primary key up here in one command, one statement. If you have a single column, that's the primary key. You can just define it in line here. They decided to wanting to give it its own name. They wanted to name it film_p key as the name of the constraint file. It's actually a physical entity that's going to be created in the database called film_p key. And so they wanted to be able to name that. If you have primary key up here defined in line, then it's going to name it some generic name that it chooses to call it. So it's the designer's choice to do it this way. Okay, it's actually using this next val construct, okay, which is called a sequencer. Okay, a sequencer is a way to populate an ever-increasing integer into a column. Remember, this is what we call a surrogate key. This film ID is not a field that has business meaning. There's no meaning inside that number besides being the primary key and be able to use this record to link to other records. So we're calling this is known as a surrogate key. And you'll notice from the database, if you go into the sequences area, that there is this sequence called film_ID_sequence. And that is this incrementing by 1 type of entity with a maximum value of a very large number and starting with 1000. So the first row inserted into the public table will have a film ID of 1000. the next record inserted in will have a record value of 1001, and so forth and so on. Okay, that's what a sequencer will do. You may have run across in your readings the idea of a serial column, which is the data type serial would go actually over here instead of integer. This is a Postgre specific type of entity. It's not available in all databases. That is basically doing the combination of what this is doing with a sequencer all in one step. So I would suggest that you understand this one more because this is more standard and common in other databases, whereas the serial data type is unique to Postgre. So you can see here that other tables as well have this type of surrogate key. Matter of fact, the actor table here has the actor ID, which is again a different surrogate key ID, a different sequencer. Every table needs its own sequencer. We don't want to share film ID sequencer with actors sequencer. So we have another one called actor_actor ID sequence. And that's this sequencer right here. Defined the same way, they're actually starting at 200 for some reason rather than 1,000 or even 1. You don't have to start any number besides 1 if you want, but they're deciding just to up the numbers a little bit higher for maybe for easier to read or something like that. So there's a sequencer on this table as well. Also in the table film, in blue here highlighted, you'll notice that there is a foreign key defined. So the language ID coming from the language table is a foreign key here to the language table. So one could understand from this that this language ID, which is a foreign key in film, is going to be the primary key in the language table. Okay, if we were to pull up the language table, you would see that language ID is the primary key of that table. And it's referenced here as a foreign ID. So we can use that relationship to join these tables together. Because in the end, the reason why you're defining all these foreign keys is so that you can relate tables together and join them and make more interesting reports and more interesting outputs from that. So that's the summary for this week's lesson of primary keys and foreign keys. Be sure to finish the rest of the reading and learn more information about other constraints like not null and default. And if you have any questions, certainly contact me. Cheers.